In this video, we're going to take a look at the covariance and the coefficient of correlation. Now here we are looking at two numerical variables, and we want to try to determine if there might be a relationship between these two numerical variables. So the first thing that we're going to look at is the covariance, which is a measure of the strength of the linear relationship between two numerical variables. All right. And what that formula is right here. So the sample covariance is COV of x comma y. All right, COV stands for covariance. The x and the y are the two numerical variables. And that is the sum from I equals 1 to n of x sub I minus x bar, which is the mean of the variable x, times y sub I minus y bar, all divided by n, minus 1. All right. Now, this can tell you if there is a relationship between the variables, but it doesn't necessarily tell us the relative strength of this relationship. And by that, I mean, suppose we have a data set with n values here. Well, what if we have another data set with ilm values? And if that's a wildly different data set, then it'll be hard to compare what this number is with the number given by the covariance on the data set of size ilm. So in that case, we want to try to find a way to normalize this data, or this statistic here, so that no matter what the size of the sample is, then we can still have some idea of the strength of the linear relationship between the two variables. And again, how are we going to do that? So we're going to introduce something new here called the coefficient of correlation, which is going to help us determine the relative strength. Can measure the relative strength of the linear relationship between the two numerical variables. And that's what we're going to define now. So we have our covariance here. That is going to be a part of the formula for the coefficient of correlation. So our sample coefficient of correlation is R is equal to COV of xy, so our covariance, divided by the standard deviation of the variable x times the standard deviation of the variable y. So we just wrote down what COV was, so just a reminder, S sub x, that is the standard deviation, which is the square root of I equals 1 to n of x sub I minus x bar squared, all divided by n minus 1. And S sub y is the same thing, but on the y variable. So I equals 1 to n, y sub I minus y bar squared all over n minus 1. All right. Now, it turns out for the coefficient of correlation, always this value is between -1 and +1. So let's discuss real quick what these values might mean. So if r is equal to +1, this implies, or this means, the two variables have a perfect and positive linear relationship. What does that mean? That means we have two variables, some x variable here and some y variable here, and all of the data points. If r is 1, that means every single data point lies on a line with positive slope. Similarly, if r is equal to -1, there is a perfect but negative relationship. And what does that mean? Well, that just means same thing, except for the slope is negative. But, oops, that's supposed to be a straight line there. So it's x, y. So there's a perfect correlation between the two variables, as in every data point lies on a line with negative slope here, if r is -1. Well, just to get a quick idea of what's going on, if we see a data set that looks like this, where it looks like there's a pretty strong correlation, then here r would be approximately 0.9. We might have a less strong correlation between x and y. But in general, it still might be moving up as we move to the right. Well, this might be something like r is approximately 0.3 or so. And then so on. We have a similar idea if the relationship is negative. And if we have a similar scatter plot, but the points are going downward, then r could be approximately -0.3. Or we can have a similar data set as this, but with the data points going downward, and that might suggest an r of about -0.9. So the closer we get to 1 or -1, the closer the data points lie on a single linear equation. And that's what this r value means. That's what that coefficient of correlation actually means. And that will end this video.